In this lesson, we talk about diffuse samples. Diffuse samples are actual GI or global illumination bounce light or indirect light, how the light interact within our scene. Without GI samples or global illumination samples or diffuse samples, we only see the effect of the direct lighting. So when diffuse sample value is bigger than 0, camera rays hitting a diffuse surface fire indirect diffuse rays in random directions within a hemispherical spread. So if you take a look at this picture from Arnold Sport, as you can see, a camera ray is fired. When this ray hits a surface, indirect diffuse rays will be generated if diffuse samples is bigger than 0. So you increase your diffuse samples, you are increasing the number of indirect diffuse rays fired from those hit points, and by doing so reducing indirect diffuse noise and getting a higher quality GI bounce. Now let's go over this concept quickly. The same scene we worked with in our previous lesson with some minor adjustments. I have this new cubical shape to help us understand diffuse samples a bit better. Also, I have turned off the left and the right quad lights, and only the white top light is turned on at the time being. This is the render that we are getting by default. You can see it in the IPR. Let's open our render settings, and here we have 3 camera samples and 2 samples for diffuse, specular, and transmission rays. Now let me decrease my camera, specular, and transmission rays to 1 and reduce SSS and volume samples to 0 because we don't have any subsurface scattering or volumetric effects in our scene. We can also zero out our transmission rays because we don't have any transmissive quality as well in the scene, but it's okay for now. Now if I run my IPR, we are gonna have this noisy render. Now let me zero out my diffuse sample, and as you can see, by looking at the IPR, we no longer see any indirect lighting or GI. We can see dark areas underneath the object. You can see how dark and black these areas are. We only can see the effect of the direct lighting at the time because we don't have any diffuse or basically indirect samples. As soon as you have a bigger value than 0, like 1, in your diffuse sample, you start to see the indirect lighting and the effect of GI or global illumination. We can actually individually see our diffuse direct and diffuse indirect render passes or AOVs. If you go to the render settings and AOVs tab, here you can search for diffuse in the inactive AOVs and add diffuse direct and indirect to the active AOVs list. Now if I run the IPR, we can take a look at our diffuse direct and indirect passes. So here is our diffuse direct, which contains only the effect of direct lighting. You can see underneath the objects where no direct light can reach is black. And in the diffuse indirect pass, we can see the indirect lighting. And if I zero out the diffuse samples, you can see this AOV becomes completely dark and black because there is no indirect diffuse rays introduced to the scene. And as soon as I increase the diffuse samples to 1, we start introducing a very noisy indirect lighting or indirect diffuse or global illumination. Now, what we have is physically correct, and our only concern is how to improve the quality and reduce the indirect diffuse noise. We can do so by increasing the number of our diffuse samples. Now remember, it is possible to increase the diffuse sampling quality by increasing the camera samples, but that would affect everything else in the scene. So if we made sure the origin of the noise is GI diffuse, and we can make sure simply by looking at the indirect diffuse AOV path, you can see all the noise is coming from here, most of it. So we can increase the number of our diffuse samples without affecting any other thing in this scene. So when we are increasing the number of diffuse samples, unlike camera samples, we are only increasing the quality of our indirect diffuse rays without affecting other ray types like camera, specular transmission, or subsurface scattering. Now, let me increase the diffuse samples from 1 to 6, and if I render the scene, the result would be like this. Let me just go to my picture viewer. Now here is the render with the current setting. If you look closely, even though the render is very noisy, the areas affected by the indirect rays are much cleaner. If you take a look at these areas underneath these objects, it is much cleaner. And the render, the noise that you see in these shadow edges are actually direct lighting noises, and we need to increase our light samples, our light source samples, to actually get rid of these noises. We do that in a moment. So as you can see, it's much cleaner if you compare it to our previous render when we had 1 diffuse samples, and I actually can just enable the indirect diffuse AOV, and we can compare these paths as well. And as you can see in the first render, when the diffuse samples was 0, we don't have any indirect lighting. Then we increased our diffuse samples to 1. Now we introduce our diffuse samples or our indirect lighting, and we get this noisy render. And finally, we increase our diffuse samples to 6 to actually have a cleaner indirect lighting path. Now in this scene, the primary source of noise is the indirect diffuse rays, but imagine if we had, for example, very broken apart lines on our spheres, or we had some very jagged edges. In those cases, we needed to increase our camera samples, right? And when we increase our camera samples, obviously we need to decrease our diffuse samples, because if we just keep increasing our diffuse samples and then increase our camera samples, what's going to happen is the diffuse samples, we know the actual diffuse sample value is the input squared multiplied by the camera sample squared. So we're going to have a huge value. So in almost all the scenes, we need to actually increase our camera samples to kind of compensate for the effects like depth of field, motion blur, jagged edges, and anti-aliasing issues. So in those cases, because we are increasing our camera sample, we need to actually decrease our diffuse samples to actually have a balanced scene and don't go through the roof with our diffuse samplings and have very, very long render times. So in this case, let's go to something like 4 camera samples and probably something like 4 diffuse samples. And if I render the scene, the results obviously would be this that we see in the picture viewer. We still have some noise in some parts of our render, but they are not caused by GI diffuse samples, and the reason for the current noise are the low value of direct light samples. So we can select the light, we have just 1 light in the scene, and increase the samples for the light to something like 4, and if I render the scene, we are going to have this clean, noise-free render. Now, 2 things to remember though. First of all, remember the actual number of diffuse samples are the input squared multiplied by the camera sample squared, right? So when you are increasing your camera samples, always make sure to decrease your diffuse samples to actually compensate for the increase of the camera samples. Also, use diffuse samples sparingly, because it is going to have a huge impact on your render time. So for example, if you saw some GI diffuse noise, just increase this value to 2, and if it wasn't enough, increase it to 3. So make sure just go 1 step at a time to basically don't have expensive renders. In this lesson, we discussed diffuse samples, and in the next lesson, we are going to talk about specular samples. See you there.